So today's video we're going to be talking about solving trigonometric equations in section 7.5 of our text. Now, a couple of ground rules we're going to lay down for solving these that are actually going to make your life a little bit easier are the following. First, you can give all your solutions in degrees if you wish. So when the textbook actually asks you to find the solutions on the interval from 0 to 2 pi, meaning find radian solutions, I'm perfectly happy to accept those solutions written in degrees instead. So to that end, the idea would be make sure your calculator is in degree mode. On this TI-30, you have this DRG button, and you can toggle between degrees, radians, and gradients. We never talk about gradients in math. We just use degrees and radians. So I want to make sure I'm in degree mode, and I am. And I'm just going to do all of my problems in degree mode. The second is give all possible solutions to each equation. Meaning we're not going to restrict ourselves to a specific interval of solutions. So again, when the author says in an exercise, give the solutions on the interval from 0 to 2 pi, not only do you work the problem in degrees if you prefer, but you just give all solutions in general. Don't worry about restricting yourself to that specific interval from 0 to 2 pi or 0 degrees to 360 degrees in degree mode. And that actually makes life a little bit easier for us if we don't add that imposition. Okay? All right, so let's outline the process of solving a trigonometric equation. Okay? The very first thing you're always going to want to do is translate any of the other 4 trig functions back into sines and or cosines. So you want to write all functions as sines and or cosines, meaning replace tangent with sine over cosine. Replace cotangent with cosine over sine when it appears in a problem. Replace cosecant with 1 over sine, and replace secant with 1 over cosine, so that you only have sines and cosines appearing in any equation that you need to solve. All right. Now, the second thing, and this is where the bulk of your algebra skills are going to come in, is you solve the equation for sine of theta and or cosine of theta. If those both appear in the equation, you solve sine of theta equals a number and cosine of theta equals a number. If only one of them appears, like only a sine of theta appears in the equation, then you solve for sine of theta equals a number. Okay? Now, once you've got that sine of theta or that cosine of theta equals a numeric value, the rest of the process is really very, very rote. You just do the same things every time. First thing you're going to do, once you have sine of theta equals a number, is you apply an inverse to solve for theta. That gives you a solution. Once you have that solution, you flip the solution appropriately to get a second solution when possible. And of course you'll see this in examples and understand it better then. And finally, you write plus or minus 360 degrees times k on all solutions. And that makes sure that you have represented every possible solution to that equation. All right, so let's look at a very simple example of this process. This is exercise number 4, where the equation is 2 times the sine of theta is negative root 2. I want to solve this for theta, all possible values of theta, such that when I take their sine and multiply by 2, I get negative root 2. Okay? All right, so everything is in terms of sines or cosines already. I now need to solve that equation for, in this case, sine of theta. To get sine of theta by itself, I'm simply going to divide by 2. That completes step 2, which was very easy in this particular example. In general, that could be the most challenging step you have to perform in a problem, though. Step 3, apply an inverse to solve for theta. In other words, I want to get theta, so I need to get rid of the sine. So I take the inverse sine of both sides of this equation. Theta, therefore, is the inverse sine of negative root 2 over 2. Now, even though this is a special angle and we would know it, I want to show you that you can, at this point, simply rely on your calculator every single time to work the problem. So, here's what I would do on the calculator. I hit inverse sine, and I need negative the square root of 2 divided by 2. And I get negative 45 degrees. So I did not have to think to get that. I just relied on my calculator. Okay? Now, think about what negative 45 degrees looks like. It's down here. And now think to yourself, is there another angle that would give you the same sign? Meaning, is there another angle I could take the sine of that will also give me negative root 2 over 2? Well, the way to realize this is to realize that the inverse sine only can work on the right half plane. The inverse sine and the inverse tangent work here. The inverse cosine works in the top half plane. So the inverse sine only can give you solutions between negative 90 degrees and positive 90 degrees. In this case, negative 45 degrees. What the inverse sine completely misses is what's going on the left half plane. So the way you take a sine inverse and flip the angle to get a second solution is across the y-axis. So you flip over here, and so that's going to be 180 degrees plus 45 degrees, or 225 degrees, and there is a second solution. Again, what that means is the sine of negative 45 degrees is negative root 2 over 2, but also the sine of 225 degrees is also negative root 2 over 2. And you can check this on your calculator to make sure. The sine of negative 225 degrees, and you get positive 225 degrees. The sine of 225 degrees is negative 0.7071, or negative root 2 over 2. Okay? All right, now, with those two solutions, the final step is to write plus or minus 360 degrees k on them. So write plus or minus 360 degrees times k, plus or minus 360 degrees times k. And what that represents is k is a counting number. It's going 0, 1, 2, 3, and so on. That's simply saying any angle that is coterminal with negative 45 degrees. You go around 360, go around another 360, go around another 360. All those different angles that are coterminal, they're all going to have the same sign evaluation. Same thing at 225 degrees. You go around 360 degrees, another 360, another 360. Those angles are all the same position, so they're going to have the same sign evaluation. This is the family of all solutions to this equation that we started with. Okay? All right, let's take a look at another example. Let's take a look at problem number 12. In number 12, the equation is cosecant squared x minus 4 equals 0. Now remember, step 1 of the process. Write all the functions in sines or cosines. I don't want a cosecant appearing there. So I realize that cosecant, that's 1 over sine squared x. If I add 4 to both sides of this equation, I get this. And now realize that the way to solve for sine, to do it simply, would be to flip this. So flip this fraction, and flip this fraction. Now, to solve for the sine, you want to get rid of the square. You take the square root, plus or minus the square root of a fourth. Now, the square root of a fourth is a half, so you're getting plus or minus 1/2, meaning we have two solutions for sine of x. Sine of x is negative a half, or sine of x is positive 1/2. All right, that completes the step 2, where we've solved the equation for the sine. Step 3, apply an inverse to solve for theta now. In this case, I'm solving for x. X is the inverse sine of negative a half. Using your calculator, again, you don't have to be thinking here, really. You just have to follow the steps. Inverse sine of negative 1 over 2 gives me the angle negative 30 degrees. Similarly over here, x is the inverse sine of 1/2. Typing that onto my calculator, inverse sine of 1 over 2, and I get positive 30 degrees. Okay, that completes step 3. Apply the inverse to solve for the variable that you're looking for. Now I have to consider, what does the inverse sine miss when you apply it? And the way I do that is to realize, again, inverse sine can only see what's going on in the right half of the plane. It could find that negative 30 degrees, right? But it could not see what was going on over here. So I have to flip negative 30 degrees over the y-axis. 180 degrees plus 30 degrees, I get 210 degrees. Similarly over here, x is 30 degrees. The inverse sine can't see what's going on the left half plane, so flip 30 degrees over. That's 180 degrees minus 30 degrees, or 150 degrees. Those are the appropriate flips that we do in step 4 to get a second solution when possible. Finally, on your solution, simply write plus or minus 360 degrees k, and you're completely done with the problem. There you have it, all your solutions. Okay. All right, let's take a look at another example. Let's try number 18. In number 18, we have 2 times the sine of 2 theta is equal to root 3. Step 1 of the process, solve this for the sine function. That's quite simple. You divide. Now I want to get rid of that sine by applying an inverse sine, and therefore I will be solving in this case for 2 theta. 2 theta is the inverse sine of root 3 over 2. So going to our calculator, inverse sine of the square root of 3 divided by 2 gives me the angle 60 degrees. That is one solution. That is one value of 2 theta that has a sine equal to root 3 over 2. Draw your diagram and say, okay, I found 60 degrees. I need to flip it over the y-axis because the inverse sine can only see the right half, over to here. So 180 degrees minus 60 degrees would put that at the position 120 degrees. There's what I get for my second solution from flipping. Now, if I write plus or minus 360 degrees K on these, I have found all the solutions to what 2 theta could equal, such that the sine of 2 theta, when multiplied by 2, is going to be root 3. But of course, we really want our solution in terms of theta, don't we? So there's one last little step here, and that is I have to divide these by 2 to get theta by itself. 60 degrees divided by 2 is 30 degrees. 360 degrees divided by 2, 180 degrees. Similarly down here, divide by 2, 120 degrees divided by 2 is 60 degrees. 360 degrees divided by 2 is 180 degrees. And so, you see, it's really not going to throw you when you have something other than theta here. You just treat it as a variable, and then at the very end, you divide by whatever number you need to get this theta by itself. Simple process. All right, let's take a look at problem number 26 now. We have 2 times tangent squared of t is equal to 3 times the secant of t. Now, very first step always, rewrite these so they're in terms of sines and or cosines. So tangent squared is going to be sine squared of t over cos squared of t. Secant of t is going to be the reciprocal of the cosine, so that's going to be a cosine of t in the denominator. And now I need to solve this for sine of t equals a number and cosine of t equals a number so that I can proceed. So how am I going to do that? Well, you may notice that you have a common denominator here of cosine squared. If I take this entire equation and multiply it by cosine squared t, I will get rid of the denominators. Okay? So let's go ahead and do that. Now, one thing to keep in mind is I'm allowed to multiply by any number I wish on an equation without changing the solution set, provided that the number I multiply by is not 0. So this is when cosine squared t is not 0 that I'm allowed to do this multiplication. And that means any solution I get that corresponds to cosine of t being 0, I would have to throw it away. It's not allowed. That probably won't arise here, though. Let's go ahead and see what we get as we multiply through by cosine squared. On the left, the cosine squared cancels. On the right, a single cosine cancels. And so now I have this equation. Sines and cosines mixed in an equation. My out for this is to apply the Pythagorean Theorem. Sine squared t is 1 minus cos squared t. Multiplying through by the 2, 2 minus 2 cos squared t is 3 cos t. And if I move everything to the right-hand side, adding 2 cos squared t to both sides, there's plus the 3t, 3 cos t, and then subtracting a 2 from both sides, I get this equation to solve for cosine of t. Now that looks like a quadratic equation in terms of cosine of t, doesn't it? In other words, if I were to let u be cosine of t, it would simply be 2u squared plus 3u minus 2. Letting u be cosine of t again. That's 2u squared plus 3u minus 2, a quadratic equation to solve. Okay? So this one can be solved by factoring, right? So let's go ahead and write the factored form of this. Let's see if this works. 2u squared plus 4u minus u is a 3u minus a 2. There's my factored form. And once I have it in its factored form, I can set each of the factors to 0. And so u, when I solve here, is a half, and u, when I solve here, is negative 2. But remember, u is cosine of t, isn't it? So cosine of t is a half, and cosine of t is negative 2, or what I have to solve now. Now, to solve this one for t, t is the inverse cosine of a half. Take your calculator again. Don't even have to think. Inverse cosine of 1/2. And I get the angle 60 degrees. Now, 60 degrees is right here. What does the inverse cosine see? It sees solutions from 0 to 180 degrees in the top half. It misses solutions down here. So I have to flip over the x-axis now. And that's easy enough. You just put a negative on the angle. And there's a second solution for that. Now over here, to try to solve for t, if you hit inverse cosine of negative 2, look what your calculator will say to you. Inverse cosine of negative 2, domain error. There is no angle whose cosine is negative 2. The range of the cosine function is between negative 1 and 1. So this does not exist. And you simply stop work here once you realize this part doesn't exist, and you continue on with what you have here, which is to write plus or minus 360 degrees k and have all the solutions to this equation that we started with. And neither of these angles make the cosine equal 0. So this condition of the cosine not being 0 is satisfied in this problem. We don't have to worry about that. All right, let's try number 38. Sine of 2t is cosine of t. Now, what I'm going to apply here is simply the double angle identity for sine. Sine of 2t is 2 sine t cos t. Now, if I subtract cos t from both sides, I can set this equal to 0, and now I have something I can factor, because I can pull a cos t out of both these terms here, leaving a 2 sine t minus a 1. Now, setting these factors to 0, cos t is 0, or 2 sine t minus 1 equals 0. I can then solve this one for sine of t. Add 1, divide by 2, sine of t is a half. We've completed the step now where we've solved for cosine and sine equals a number. So now, to complete the process, you use the inverse trig function. T is the inverse cosine of 0. On your calculator, inverse cosine of 0 gives you, inverse cosine of 0 gives you 90 degrees. Now think about flipping 90 degrees to get a second solution. Cosine inverse sees the top half. I need to flip over down to negative 90 degrees to get a second solution. In other words, the cosine of negative 90 degrees is also 0, and you can always confirm these. Cosine of negative 90 degrees is 0. Okay, so these are my two solutions from this branch of my work. On this branch over here, where sine of t is a half, t is going to be the inverse sine of a half. On your calculator, inverse sine of a half gives us 30 degrees. 30 degrees is right here. The inverse sine only sees the right half, misses the left half, so I have to flip over to 150 degrees to get a second solution. Once you have all these solutions written, go ahead and write plus or minus 360 degrees k, and now you have all possible solutions to the equation. this and this, and you're done with the problem. All right, let's try one more problem today. This is number 60, where we have 8 times sine squared of x plus 6 sine of x plus 1 equals 0. Okay. Now, this we try to factor. Well, 8 times 1 is 8. Are there 2 factors of 8 that add up to 6? There sure are, 4 and 2. So 8 sine squared x plus 4 sine x plus 2 sine x plus 1 equals 0. And now I can group these in pairs. In the first pair, pull out a 4. 2 sine x plus 1. Sorry, pull out a 4 sine x. There we go. On the second ones, pull out just the number 1. The common factor of 2 sine x plus 1, leaving behind a 4 sine of x plus a 1. Now, setting these individual factors to 0. I can solve each one for sine of x. Here, sine of x is going to be a negative 1 divided by 2. Here, sine of x, you subtract 1, then divide by 4. So, applying your calculator, x is going to be the inverse sine of negative a half. On our calculator, inverse sine of negative 1 over 2 gives us negative 30 degrees. We have to flip over the y-axis when we're using inverse sine. So 180 degrees plus 30 degrees, 210 degrees. And if you want, at this point, you can write your plus or minus 360 degrees k, and you won't have to come back to this branch of work at all. Now over here, sine of x is negative a fourth, so x is the inverse sine of negative a fourth. On your calculator, this is not one of your special angles, so you definitely need a calculator for this. We get the angle negative 14.48 degrees approximately, which is close enough. We're not going to write down the exact value here. And I want to flip that to get a second solution. So think about it, negative 14.48 degrees here, and I want to flip it here. That's going to be 180 degrees plus 14.48 degrees, or 194.48 degrees. Finally, write plus or minus 360 degrees k, and you have all your solutions now to this problem. Okay. All right, so it's a pretty straightforward process, solving trigonometric equations. We've broken it down into that 5-step process. Step 1, make sure everything is written in terms of sines and cosines. Step 2, solve for either the sine or the cosine that's appearing in the problem, in this case sine. Step 3, hit inverse trig function on your calculator to get a solution. Step 4, flip to get a second solution. You flip over the y-axis to get the second solution when using inverse sine. You flip over the x-axis when you're getting a second solution from using the inverse cosine. Now, if you had used the inverse tangent, in that case you would be flipping over the origin. But since we're writing everything in terms of sines and cosines, you'll never have to worry about that kind of a flip. We'll keep it very, very simple. Remember to write plus or minus 360 degrees k on all your solutions, and you will have represented every possible solution to the equation. All right, so please go forth, try working the exercises for section 7.5, And as always, let me know if you're running into any difficulties so that we can address that.